Use the definition of the derivative to find the derivative of the function x squared plus 3x. Okay, let's start with the definition of the derivative. Okay, our definition of the derivative is based on a limit, and it's the limit as delta x goes to 0 of the difference quotient, and that's f of x plus delta x minus f of x all divided by delta x. Now the difference quotient is basically the slope of the secant line, and when we take the limit as delta x goes to 0, we're taking the limit as the 2 points that where the secant line intersects the function get infinitely close together and become 1 point. Okay, so let's start with this. Let's start with this expression that we're going to take the limit of. Okay, so let's start here. What is f of x plus delta x minus f of x all over delta x? Okay, well, let's start with the f of x plus delta x. Okay, so that basically means we substitute x plus delta x into x in our function. So this x plus delta x is going in here for this x and here for this x. So what does that look like? That's x plus delta x squared plus 3 times x plus delta x. So we have to do some multiplying and some combining like terms. Okay, so we have to FOIL this out. So that's x plus delta x times itself, x plus delta x plus, and we can distribute the 3. Okay, so that's 3x plus 3 delta x. Okay, so let's FOIL this out. First times first, outer times outer, inner times inner, and last times last. Okay, so when we multiply this out, first times first, x times x, which is x squared, outer times outer, which is x times delta x, inner times inner, that's another x times delta x, and last times last is delta x times delta x, or delta x squared. Okay. Then we have a plus 3x and a plus 3 delta x. Okay, so combine like terms. So it looks like we have an x plus delta x, another x plus delta x here. So that's x squared plus 2 of these x times delta x's plus delta x squared plus 3x plus 3 delta x. Okay, so now we're not done, but this here is the x plus delta x in that difference quotient. Okay? So now let's plug this back into the difference quotient. So we have the f of x plus delta x, that's x squared plus 2x delta x plus delta x squared plus 3x plus 3 delta x. Okay, I'm going to erase this equal sign because now we're doing something a little bit different. Okay, so that's in the numerator, that's the first term, and then we're subtracting off the original function f of x, which is x squared plus 3x. And all of that is divided by delta x. So what we basically did is we first sort of figured out this guy here, the f of x plus delta x, plug that back into the difference quotient, and now we're down here. So we have some canceling to do. We have a x squared and a minus x squared. Okay, we have a 3x here, and we have a minus 3x here. So our f of x plus delta x minus f of x, all divided by delta x. So it looks like we have a 2x delta x plus delta x squared plus 3 delta x, all divided by delta x. I'm going to zoom in a little bit so we could maybe see everything. Oop. Okay. So each term in the numerator here has a delta x. So we can factor out a delta x here. We have a delta x times, well, what's left? In this first term, we have a 2x. In the second term, well, we factored out one of those delta x's, so we have another delta x, so plus delta x. And here we factored out the delta x, so we have a plus 3. Okay. And we still have a delta x on the bottom. And now, this is what we want to do. We want to evaluate the limit involved in the definition of the derivative. We need to eliminate the delta x in being a factor in the denominator. Because if we're going to plug in 0, we know we can't have 0 on the bottom of a fraction. And that's what we've done here. So this delta x on top and this delta x on the bottom will cancel. So our difference quotient simplifies to 2x plus delta x plus 3. Okay, we haven't really done any calculus here. This is a lot of algebra. Now we're ready to do the calculus. The calculus in this problem is applying the limit. Okay, so now we could say, let's go back to black, the limit as delta x approaches 0 of f of x, f of x plus delta x minus f of x all over delta x. Well, we've evaluated the difference quotient here and simplified it. So now we're at the limit as delta x approaches 0 of 2x plus delta x plus 3. So now we can apply the limit. So this is where the calculus comes into play. And the delta x going to 0 has nothing to do with the 2x, and it has nothing to do with the plus 3. But this delta x here, this goes to 0. Okay, so this becomes 2x plus 0 plus 3, or simply 2x plus 3. And so, now that we've evaluated the limit of the difference quotient, that is f prime of x. That's the derivative of our function. And we are done. Now, it would have been a much, much quicker process if we applied the power rule, but that's not in the scope of the problem here. We wanted to use the definition of the derivative to find the derivative of f of x. Okay. Just again, I just really want to note how algebraically intensive this problem is. And this is calculus. Calculus is a lot of algebra. So, if your algebra skills are lacking, the best way to be successful in a calculus course is to really brush up on your algebra skills. Okay, that does it for this problem. I hope this was helpful.